Okay, we're beginning Unit 12. This is Lesson 1. This is Pyramid Fundamentals and Associated Nets. So let's take a look at some terms to see what we got. Once again, let me remind you that if you have any kind of thoughts that you might have a question or something, get yourself a piece of paper, pen, pencil, or whatever so that you can prepare to take note of what your question is so that you can bring it to class tomorrow and we will cover that before we do any kind of work. Okay, so let's take a look. Definitions and such. A pyramid has these terms associated with it. First off, it has a base. The base is a polygon. The pyramid is a special case of a cone in which the base can be any shape. Okay, the second thing it has is it also has lateral faces. So if the base is a polygon, the number of lateral faces is equal to the number of sides of the polygon. Also, let me note that since it is a pyramid, this means that each one of the lateral faces will be a triangle. Okay, every cone also has an apex. This is the point at the quote top unquote of the pyramid. It can be whichever direction. It depends on the way the pyramid's turned. Okay, it is sometimes called the vertex, although the pyramid has other vertices in the base. Okay, a pyramid also has lateral edges. These are the edges of the lateral faces. And it also has base edges, which are the edges of the base. Okay, some more definitions and things. So let's see. Pyramids also have these terms. There's an altitude or an height. Okay, and that's simply the perpendicular distance from the apex to the base. The slant height. Now this is different because this is the perpendicular distance from the apex along a lateral face to the midpoint of the side of the base. So this one is slanting along the side of the pyramid the whole time. So you have to be careful which one you're using because the altitude is used to determine the volume. The slant height is used to determine the surface area. Okay, the pyramid type. This is named according to the type of the base. So if the base is a square, it's a square pyramid. If the base is a rectangle, it's a rectangular pyramid. If the base is an octagon, it's an octagonal pyramid. If the base is a triangle, it's a triangular pyramid, and so on and so forth. Okay, the apothem generally refers to the apothem of the base, although the triangular faces also have apothems. Generally, you're not going to use the apothems of the face of the triangular face unless it happens to be equilateral triangles. Okay. However, you will usually use the apothem the uh, to find the height or the slant height using the Pythagorean theorem because it will be part of a right triangle. Okay, so now what we're going to do is we're going to label with arrow pointers the indicated parts of this 3D representation of a pyramid. So this is what a pyramid looks like. Notice what they've got going here. The apex is the vertex, which in this orientation is at the top. The altitude goes from the center of the base to the vertex or apex, and that is always going to be, it won't always be the center, but if it's a regular base, that's generally what it is. If it's a right if it's a right pyramid, then that's the way it will be. Okay, the slant height, as you notice, is going up the face of the side here. It cuts the base edge into equal pieces, and it's also perpendicular to the base edge as it goes up to the apex. Notice that this forms a right triangle inside the pyramid. So that is very important for a lot of things that we're using, because if they give us the slant height and they give us the this part down here, the apothem of the base, then what happens is you can find the altitude by using the Pythagorean theorem, or if they give you the altitude or the height and this at the bottom of the base, then you can find the slant height very easily. Okay, And then the second thing they want us to do is label with arrow pointers the indicated parts of this pyramid net. So if we took this pyramid, cut it apart, and unfolded it, it would look something like this. Okay, so if you notice here, you've got a lateral face, a slant height is noted in one of these triangular faces, the lateral edge is indicated, the base edge is indicated, and the base is indicated. Okay, let's move to some examples. So example 1, 2, and 3 we've got on this one slide. So name the lateral faces of this pyramid. That's the first thing we're going to do. So the lateral faces of this pyramid are simply going to be triangles. So those triangle ABE, triangle BCE, triangle CDE, and triangle ADE. Notice that since it is a square pyramid or rectangular pyramid, because we don't know for sure if it's square, then we have 4 triangular faces, one for each side of the rectangle. Okay, they want us to name the pyramid type. The pyramid type is a rectangular pyramid, named for the shape of the base. Okay, example 2, they want us to name the lateral edges of this pyramid. So there's a bunch of lateral edges because if you notice these edges of the triangle going up to the apex, those are all lateral edges, as well as the base edges are also lateral edges because they form part of the triangle. Okay, so AB or AE, BE, CE, and DE are all lateral edges without anything else. AB, BC, CD, and AD are additionally base edges and lateral edges at the same time. All right, example 3. Name the base edges of this pyramid. So in this case, we just repeat these last 4. So we have AB, BC, CD, and DA. Okay, example 4, they want us to find the slant height of this rectangular pyramid. So notice what we've got here. We've got a rectangular pyramid. They're telling us that the altitude or the height of the pyramid is 8 feet from the base to the perpendicular distance from the base to the apex. They told us that the side of this rectangle is 6 feet. So that means that this little part right here, because it goes from the center of the rectangle, is going to be 3 feet long. So this means that we can construct a little triangle that represents this dotted line triangle in here, just so we can see it more clearly. The slant height is going to be the hypotenuse. The 8 is going to be one leg, and the 3 is going to be the other leg. So this means we use the Pythagorean theorem, which says if you take the sum of the 2 bases squared and add those together, then you will come up with the hypotenuse squared. So in this case, we have the slant height squared is equal to 8 squared plus 3 squared. So the slant height squared is equal to 64 plus 9. So the slant height squared is equal to 73. Okay, we don't want the slant height squared, so we find the slant height, which is the square root of 73, because that's how you reduce a square to its base level. So when you take the square root of 73, you're going to find that the slant height here is approximately 8.54 feet. Okay, example 5, and this is the last one for this lesson. But what they want us to do here is this time we're going to kind of reverse the process from example 4, because they want us to find the height or the altitude of this pyramid if the perimeter of the square base is 8 square root of 3 inches. Okay, so the first thing we do is we divide by 4 to find out what each side is. So we were told that the slant height here is 22 inches, so we need to find out how far this little piece at the bottom of this dotted triangle is. So first thing we do is we find the length of a side, which means that we either multiply 8 square root of 3 by 1/4 or divide 8 square root of 3 by 4, which gives us 2 square root of 3. So 2 square root of 3 divided by 2, which is what they're noting here with this little blue triangle, is equal to the square root of 3. So that means this little dotted line from the center to the edge is square root of 3 long. We were told that this is 22 inches going this way. So once again, we're going to do the Pythagorean theorem, but this time one of the sides, the 22, is our hypotenuse. So this time we're going to have h squared, which is the height of the pyramid, plus the square root of 3 squared is equal to 22 squared. So when we do this, we get h squared plus 3 equals 484. Subtract the 3 from both sides gives us 481. So h, when we take the square root of both sides, becomes equal to the square root of 481, which is approximately 21.93 inches. Okay, once again, as I noted earlier, if you have any kind of questions, jot them down on a piece of paper. Bring them to class tomorrow. We will be more than glad to talk about those before we get started on any kind of work. Thank you very much. See you later. Goodbye.